when we write numbers using scientific notation, there's two ways that we can do this. First way is we can take a number in standard form, which are numbers that we see every day, 39.47 or 348, 7, okay, any numbers like that, and we change them from standard to scientific notation. Okay, scientific notation has a number that it has a base number, okay, we could call this number the base number, that is between 0 and 10. It is greater than 0, but it's less than 10. Okay, so has to be at least 1. Okay, it can't be 0.9 or 0.8. It has to be at least 1, but it has to be less than 10. Okay, so we can't have 10 as our base number. It has to be less than that. 9.9. Okay, that works. It has to be less than 10. Okay, so greater than 0, or excuse me, at least 1, but less than 10. Okay, and then we're going to have our base number, and we're going to have it multiplied by some power of 10. Okay, so this is 10 to the first power. Okay, so in scientific notation, this means that the true value of this number means that we're just going to move our decimal one time to the right because that's a positive exponent. And this number is really 39.47. Because the purpose of using scientific notation is to take really large numbers or really small numbers, and instead of writing a whole bunch of zeros or just a really, really small number, we just take it and put it in a base number that's at least 1, less than 10, and we give it a power of 10, and it makes it a lot easier to understand and to write these numbers. Okay, so that's the first way. The second way is to take numbers that are in scientific notation and we write them in standard form. Okay, so we're going to do 2 examples from each way to do this. Okay, so our first 2 examples that we're going to look at are our first way. We're going to take numbers that are in standard form and we're going to write them in scientific notation. Okay, so we're going to be on this side of the paper first. So I'll go ahead and cover this up. All right, we'll get to that in a second. Okay, so we're going to take numbers that are in standard form. We're going to write them in scientific notation. Okay, so here's kind of an easy way to remember how to do this. Okay, I call it caret to decimal. Not a carrot you eat, not a carrot that's on a diamond ring you have, but a symbol that is usually used in revising papers in English class. It's called a caret, and it's actually spelled C-A-R-E-T. Okay, I call it caret to decimal. Okay, so there's 3 steps to this. The first step is called put it. So what we're going to do is we're going to put the caret in our number. Okay, and I know it's kind of small down there, but it says left to right after the first digit that is not 0. Okay, so left to right, that's how we read. So what we're going to do is we're going to look at our number. We have 52,390. And we're going to start on the left side, and we're going to put a caret after the first digit that's not 0. Okay, so we're going here, and all of a sudden I have a 5. That's not 0, so my caret is going to go after the 5. Okay, so now I have a caret there. Step 2 says find the true location of the decimal. All right, well, in this number, the decimal is not shown, but we should know, and it's understood, that the decimal is after this 0. Okay, so really that decimal is right there. Okay, so step 1 was put it. I put my caret after the first digit that's not 0 from left to right. I found the true location of my decimal, and now I'm going to go caret to decimal, right? C to D, that's alphabetical order. Okay, so my decimal is going to go right here now, right? So this is 5.2390 times 10. Now I got to find my power, okay, or my exponent of 10. All right, so now all I do is I go from my caret to my decimal, and I count how many times I'm going, how many times I'm moving. So 1, 2, 3, 4, right? I moved the decimal 4 times that way. Okay, so my exponent is 4, and I went to the right, so my exponent is positive. Okay, so think about it like on a number line. All right, I went from caret to decimal, and it took me to the right, so my exponent is positive. Okay, another way to kind of check your work is if we have a exponent of 10 that is positive, our number is going to be greater than 1. All right, so we have a number that is greater than 1 there because we know the true value of that number is 52,390. Okay, so our second example, we have a really, really small number. We have 0.002969. Okay, so we're going to follow the same steps. We're going to go caret to decimal. So step 1 is put it. All right, so left to right, first digit that's not 0. Okay, well, I can't put it there. That's 0, 0, 0, 2. So my caret's going to go right here. Okay, so I could go ahead and write 2.969 times 10, but I got to figure out my power, okay? So now find the true location of the decimal. Well, in this case, it's already given to me. It's right there. All right, so now I just go to step 3, and it's C to D, caret to decimal. And I'm going 1, 2, 3 spaces, but this time I went to the left. So my exponent will be a -3. Okay, so that's all you do. Going from standard form to scientific, there's 3 steps. We put in the caret from left to right after the first digit that's not 0. Step 2 is find the true location of the decimal. So in this case, if we have a number that's greater than 1, usually the decimal is not going to be there, but we need to understand that it's at the end of the number. Okay, and then down here, the decimal is given to us. And then from there, we just go caret to decimal. Remember, C to D, it's in alphabetical order. And if we go from the caret to the decimal and we're going right, our exponent's positive. Caret to decimal went to the left, our exponent is negative. Okay, now if we go from scientific to standard, it's a little simpler. All we have to do is move the decimal the same number of times as the exponent. And then the sign of the exponent is going to tell us which direction to move the decimal. Okay, so if we have a positive exponent, we're going to move the decimal to the right. If we have a negative exponent, we're going to move the decimal to the left. So let's look at our first example. We have 6.138 times 10 to the -3rd. Okay, so all I'm going to do is I'm going to move my decimal 3 times. And since my exponent is negative, I'm going to the left. So I can look at this number and I can go 1, 2, 3. Okay, and in these holes right here, I'm going to put zeros. Okay, so I'm going to rewrite my final answer. It would be 0.006138. That's all I do. It's a really small number, right? Because my exponent was negative. Okay, last example, we have 8.751 times 10 to the 5th. All right, I know how many times I'm moving my decimal, I'm moving it 5 times, but the sign of the exponent tells me it's positive, so I'm going to the right. So 1, 2, 3, 4, 5. So I can add a couple zeros in there, and that's real crowded, so I'm going to rewrite my answer. So I have 875,100. Okay, and in this case, I want to look at where I need to put a comma, right? Because I don't just want to write 875,100 because I know that's 875,100. So from right to left, I'm going to put my comma there, right after each group of 3 numbers. Okay, so that's how we do it. We can take numbers from standard form and put them in scientific notation using caret to decimal. And from scientific to standard, all we do is move the decimal the same number of times as the exponent. Remember, if we go to the right, we have a positive exponent. Positive exponent over here means we go to the right. If we have a negative exponent, we go to the left. Same thing over here. Negative exponent went to the left. So that's how we write numbers using scientific notation.